Okay, number 4, we're going to take another look at the rest of the video. I edited it because there were some errors. Sorry about that. B minus 1, all divided by 2b minus 6 plus 5/3. So our first step when you're adding, and it's not an equation, so I cannot clear the denominator in any way. I have to just work it out and figure out the lowest common denominator. So the lowest common denominator for this one, I would have 2b minus 6, which can factor to be 2 times b minus 3. I don't necessarily need to do that for this one, but sometimes I want to do that to see if there's any shared factors that I can filter out. And then this 3, so there's nothing common there, so I'm going to multiply 3 times that. Now I'm going to write that as 6 times b minus 3. So that way I make sure I catch that 6. Last time I think I just wrote the wrong number by mistake. So here we have on the first fraction, the missing factor is 3. So I'm going to multiply top and bottom by 3/3. On the right hand fraction, 5/3, the missing fraction is that 2 times b minus 3. So I'm going to write that as a fraction. Now I need to just distribute. So I'm going to put parentheses around my b minus 1. So I end up in the top, I'm going to have 3b minus 3. And then in the denominator, I would have that 6b minus 3 once I calculate all that out, or 6 times quantity b minus 3. And then I'm going to add on the other side. I'm going to distribute this 5 times 2 times b minus 3. So that gives me 10b minus 30 in the numerator. And then on the bottom, I have 6 times quantity b minus 3. Then carrying all that down, I would have just do the operation in the entire top. So I have 3b and a 10b, so I have 13b. And then a minus 3 minus 30 would be minus 33. And in the denominator, I can actually multiply that out to be 6b minus 18 if I want, or I could just leave it in the factored form. So that is my final answer for that one. So number 5, I would like you to try it on your own. Just stop the video. If you already watched the video before, I'm making a correction on this. I just didn't distribute my 4a correctly. So sorry about that. We will go ahead and work this one out now, but stop it and try it yourself, figuring out what the lowest common denominator is and how you can adjust to write equivalent fractions. Okay, so on this one, we notice the LCD is a plus 3 times a minus 3, two binomials. 4a over a plus 3 is the first fraction, so we need to multiply top and bottom by a minus 3 to get that common denominator. That's the missing factor. And then on the second fraction that we're subtracting, we will have the 4 over a minus 3. And we're going to multiply by a plus 3 top and bottom so we can get the common denominator. Now here's where we need to be careful. I need to be careful to distribute carefully. So in the top, we for the first fraction, we're going to get 4a squared minus 12a. And in the second fraction for the numerator, I'm going to write that subtract 4 as a plus -4, and then I'm going to go ahead and distribute. So I have -4 times a would be minus 4a, and then minus 4 times 3 will be minus 12. And that's all divided by my lowest common denominator, which I'm going to leave factored for now in factored form, just in case I can do something with that later to simplify. I don't think we can, but we just always want to try to check. So now we can just combine like terms here. 4a squared minus 16a minus 12, all divided by the, we can actually write it as a squared minus 9. I know that there's not going to be anything that simplifies down further. And that would be our answer. We could factor out a 4 out of the numerator, but we're not going to worry about that. Number 6 is a complex rational. I'll show you a couple of different ways that we can tackle that. So, so we could just write this actually as a division problem. So we have x minus 3 over x is our top fraction. This we call a complex rational, or sometimes fractions within fractions. So we have x minus 3 over x, and then it's really saying divided by, is this big fraction bar here, over x minus 3 quantity divided by 16. So we can write that as the divided by the x minus 3 over 16. And then our process is we would multiply by the reciprocal. So then in the next step, I would do x minus 3 over x times 16 over x minus 3. And then I could just reduce the x minus 3's, and that leaves me with 16 over x, which is a really good method for this one. It works out really simply. I am going to show you a different method just so you can learn it. So I just I erased the first method so I can show you, this other one with room here. So we would want to look at what the common denominator is. And for this, if I look at all the denominators here, so I have a fraction in the numerator, x minus 3 over x. So I have a denominator of x for that one. And then in the other fraction below, remember we have fractions within fractions, I have x minus 3 over 16. So I have a 16 in that denominator. So my LCD would actually be 16x. And if I multiply the numerator, this x minus 3 over x times 16x over itself, 16x, it's really like multiplying by 1, right? Let me get rid of those little time symbols. I don't need those. So I have the x minus 3 over 16 times 16x as well. If you want to put those like over 1 to make you feel better about balancing out the fractions, sometimes that's helpful. But then what I'm going to do is when I multiply, I can reduce this whole numerator. So I have 16x and in the numerator with an x in the denominator, so I can reduce out the x there. Okay. And then in the denominator, I have that x minus 3 over 16, and my 16s will reduce out. So then when I go ahead and just kind of clean it up and rewrite everything, I have x minus 3 in parentheses. You have to add those parentheses around, times the 16. So I would have 16 times x minus 3. I'm just going to leave it already broken apart. All divided by, in the denominator, I'm left with x minus 3 as the quantity times x. And those x minus 3's reduce to 1. And it leaves me with that 16 over x. So I get the same answer. It's more work doing the second method that I showed you for this particular problem. But when they get more complicated, this second method is really the one you want to use. And so we'll practice more with those. I just wanted to touch on it for this unit, but it's really not review for most people, so we'll hit on it a little bit later as well. So number 7 reads x squared over 4 plus 16 over x, all divided by 16 over x squared. So another complex rational expression, but since it's fractions within fractions, we can multiply the numerator and the denominator by the lowest common denominator of each fraction. So here I have, again, I have a 4 in one of the numerators and an x. So over here, that's my 4x. And then I also have an x squared in the denominator, but since I already have an x, here's that x squared is represented, if I just write one more x. So if I have 4x squared, all my denominators will divide into that without a remainder. So I can multiply by that. I'm going to place that there. So if I multiply the entire numerator, that's what I have to do, by 4x squared, and the entire denominator, in this case I only have one fraction, but a lot of times I have more, by 4x squared. And remember that those are kind of like over 1. Sometimes that's a good idea to do so you just don't get off kilter. And then I'm going to distribute that 4x squared in the top. I need to do that. So one thing I can do is just now write that 4x squared off to the right of that 16 over x. I don't need to do it on the second one because I only have one term in the denominator. So now I can reduce. So I have 4x squared times the x squared over 4. So the 4's will cross out. And then I have 16 over x times 4x squared. So one of the x's crosses out. So my goal is to have no denominators left in the numerator, in that top fraction. Then on the denominator, this 4x squared times 16 over x squared, and the x squareds will reduce down to 1. So what I'm left with is, in the numerator, I have x squared times x squared, so that's x to the 4th, plus 16 times 4x. So I have a 64x there. And then all divided by 16. And I could factor an x out of the numerator, but there's no x in the denominator left to worry about that. So my final answer is x to the 4th plus 64x over 16. So for number 8, you may want to try that method on your own. So we'll leave that one as a try it, and then I'll write the answer down. So the try it reads as 4 over 25 plus 1/4, all divided by a over 25 minus a over 4. I mean, you could combine that top fraction, you could put them together first, but let's try to use the common denominator method, clearing fractions within fractions. So for this, I've just figured out that my LCD is 25 times 4 equals 100. So I'm going to multiply the entire top by 100 and distribute. So I'm really just going to multiply every term by 100. And I could write that over 1. And then in the denominator as well, I'm going to multiply every term by 100. And then I'm going to go ahead and reduce if possible, which I should be able to do if I picked correctly. So 100 over 25 will reduce down to the 4 over 1. 100 over 4 reduces to 25 over 1. Same kind of thing with the denominator. I'm going to end up with 4 over 1. And then I have the a times 4 times 100. Will leave me with 25 over 1. So now when I go ahead and kind of clean this up, so to speak, I have a 4 times 4 in the numerator is 16 plus 1 times 25. All divided by 4a minus 25a. And from there, I'm just going to go ahead and add like terms. And so my final answer ends up being 41 divided by negative 21a, or I really want to center that negative to be negative, and then 41 with the fraction bar lined up with the negative over 21a. Okay, thank you for watching.